All right, so I'm actually going to talk about how somebody transitions from studying Arctic tectonics, really old rocks, right, to remote sensing, GIS, and NASA satellite data. So this is a picture of me in about 40 years. So about a year ago, my dad asked me to put a new flashing around our chimney. It's the piece of sheet metal that keeps water from coming into your house. And so he didn't believe that I had installed it correctly. And I didn't want him to die climbing on the roof to check it out. So we got about a $40 drone from Target. And this is my dad flying it, that's me. And we were going to see, hey, what can we see? Can we figure out something using a different perspective? Can we take a look at the roof and figure out if Patrick really messed it up? And we saw a few things we didn't really anticipate seeing. For scale, that bush is about 2 meters across right there. And we saw some interesting stuff. You see some vegetation, things look a little different. But the really important things came up when you saw my dad's bald spot. Right there. And I had the sweet, sweet vindication of saying, Dad, I installed that flashing correctly. Eat it. Okay? And so when you really think about it, if you sort of amp this up a little bit, and sort of think, well, hey, if I had some metadata on this, if I said I knew how I collected this data, the time of collection, and repeated this over and over, I could really track my dad's bald spot through time. And I could know a lot more about vegetation distribution, maybe water. And so this is basically what NASA Earth observations are, right? So a souped up and way better technology, better optics, way of looking at things from a different perspective. And coming from a sort of Arctic tectonics, ancient tectonics perspective, really, I was like, I know some things about remote sensing. I knew about these satellites, right? And that's nothing. So I was so shocked when I came to my new job to learn about all this other remote sensing data and the power that we can address with that. So keep that in the back of your mind. Back to the really old rocks. So this is the painted wall in the Black Canyon of the Gunnison National Park, where I had a wonderful opportunity to work there for just a short period of time. It's one of the most beautiful places on Earth. And that wall is about 2,250 feet tall. They have some really amazing resources there, amazing wildlife, archaeological resources, and really wonderful people that are working there, but want to understand their landscape and the way things are operating in the natural system of the park, but they don't have the bandwidth necessarily to do that all the time. And lots of national park areas have amazing things. There I'm dancing a Joshua tree on Christmas about a year ago. And so each park has these amazing things to offer, but they face really fantastic challenges that are really difficult to meet by traditional means. This is Sarah Howard, a biologist at Amistad National Recreation Area, and that's Arundodonax, or giant cane. It's an invasive grass species that crowds out native vegetation along riparian corridors and wreaks havoc on natural ecosystems. And so the way to manage these sorts of resources is with better geospatial data, so that park managers can really think about the way they're designing their management strategies. And so I think this fits really well within the context of ESIP, right? So I had ESIP described to me as sort of a group that's leading the way in promoting the collection, stewardship, and use of Earth science data. This is Gates of the Arctic National Park, where I sort of started my time as an Earth scientist. And if you want to, check in on your kid and how they did putting in a flashing, you can call my dad. But if you want to learn more about sort of integrating Earth science data into decision-making processes, call NASA Develop. That's who I work for now. And we conduct sort of 10-week interdisciplinary projects. Here are a couple examples. So this partnered with the Maryland Department of Agriculture, the USDA, USGS, and EPA to study so the team created a GUI, a graphical user interface, for assessing fields enrolled within a crop program. This one partnered with the USGS Woods Hole to assess suspended sediment concentrations and define the empirical relationship between those and satellite-derived parameters so that they could better assess variation in the Plum Island estuary through time. Go see that poster tomorrow, 2772 tomorrow. And so go see it. So back to the really old rocks, right? So I had this transition from thinking about things very different than NASA data than remote sensing. But the really powerful thing was how you can learn so much more, really help people with the data. And I no longer have to think about rocks that are 450 million years old. I can think about my dad and the way that Earth science data and NASA data can help decision makers and people in really wonderful places like the National Park Service. So please look us up. This is the Applied Sciences and Capacity Building website and the Develop website. Thank you.